In this short video, I'm going to try and demonstrate how football boots can alter function, as well as some potential solutions which may help people who have recurrent injuries. The main difference between a football boot and more traditional shoes, including trainers, is the relative heel height. The degree of heel height is determined by the difference between the thickness of the material beneath the ball of the foot and underneath the heel. This has been given many different terms which include the heel-toe drop, offset, pitch or differential. In the trainer shown, it can be seen that the material beneath the heel is higher than that beneath the ball of the foot, and thus there is a relative differential. By contrast, the material beneath the heel and the ball of the foot in this football boot is the same, and therefore the boot is essentially flat. We are able to analyse the way the foot loads whilst walking and running in shoes by placing insoles that contain force sensors inside the shoe and recording the relative force during activity. This video shows someone walking in a pair of trainers and shows how the force transfers from the heel along the outside of the foot to the ball of the foot. The green curve depicted here is the amount of force beneath the foot during walking, and this is termed a force time curve. The blue curve is the pressure beneath the foot, which is a measure of the force over a relative area, but we will concentrate on the force time curve. To explain how this is recorded, we need to have a basic understanding of how force is applied to the foot. The centre of mass of our bodies is located in the stomach area and is represented in this picture by the blue circle. As the heel contacts the ground and we load the foot, the centre of mass is moving downwards, and thus the force beneath the foot increases until the foot has contacted the ground and we have reached the first peak of the force time curve. As the opposite leg swings through, our centre of mass moves up slightly, and therefore the force beneath the foot reduces and there is a dip in the curve. As the opposite leg approaches ground contact, the centre of mass is once again moving downwards, and thus the force is increasing and we reach the second peak. As the foot lifts from the ground, the force will reduce until there is no force beneath the foot, and this leg is now swinging through for the next step. If we look at this step again, we can see how the force initially increases beneath the heel, then starts to reduce until it builds once again beneath the ball of the foot. If we look at the force time curve again in trainers, we can see that the two peaks have relatively similar values. By contrast, in football boots, it is very common to find a much lower value for the first peak, as the heel is in contact with the ground for a shorter period of time. This is usually because the flat nature of the boot has placed more stress on the calf muscle, and it results in an earlier heel lift. This is a video of the force beneath the foot in a pair of football boots. Whilst it is possible to place small heel lifts within a boot to reduce the extra stretch to the calf muscle, there is a limit to how much people can tolerate within the boot. As a result, it is common for us to have football boots adapted so that the lift is incorporated as part of the boot, as in this example. Asics incorporate a 1 centimetre heel raise in all of their football and rugby boots, and this type of modification can be very beneficial for children as they are growing and the growth results in muscle tightness, exacerbating the problem. The next problem in football boots is the increased force beneath the front of the foot. The narrow nature of football boots, combined with the position of the studs, can increase the force, and many professional footballers wear their boots 1 to 2 sizes too small so they can feel the ball, exacerbating the problem further. As can be seen in this example, it is very common to have increased force concentrated beneath the big toe, the joint of the big toe, and the joint at the base of the little toe. As part of my role with the Vasily think tank, I was asked to design a sports orthotic that would be suitable for football boots. Based on my experience with professional footballers and the results of the in-shoe force analysis, I was able to incorporate a number of factors in the design of this orthotic. At the heel, there is a small raise to try and counter the flat nature of the boot. This is also angled so that it is slightly higher on the inside compared to the outside to try and improve the position of the heel. This is termed a medial wedge. There is some support in the arch area and by bringing this slightly closer to the heel, we're able to provide slightly more support with less material, which helps with fitting the orthotic in the tight nature of a football boot. There is a cut-out area beneath the big toe joint, which tries to encourage better movement of the joint and reduces some of the force in this area. There is also a small raise, termed a metatarsal dome, which sits just behind the ball of the foot and helps to improve function through this region. In this example, we can demonstrate how the force beneath the foot is spread out and thus reduced by the orthotic. Due to some of the problems associated with football boots, I teamed up with some designers to develop a bespoke football boot, which allowed us to incorporate features within the boot unique for each individual. The company, prior to Lever, produced the Assassin, where the stub plate was moulded to a scan of the foot, allowing it to be supported appropriately. This stub plate was manufactured using laser sintering, which is similar to 3D printing, and represents the state of the art for football boot manufacture. In summary, the flat nature of football boots can affect the force beneath the foot and place increased stress on the calf muscle or trim function. The tight fit and stub positioning also changes the load beneath the foot, and these factors can contribute to injury of the foot, ankle and leg. Simple modifications and an orthotic specifically designed for football boots are able to modify these factors and hopefully reduce or prevent injury. I hope you found this interesting, and please feel free to contact us should you have any questions.